Hello there, and welcome back to the Sleep Science. The room around you softens into shadow. Your blanket gathers around your shoulders like the layers of a nebula wrapping a collapsing star. The ceiling overhead could be the dome of a planetarium or the inside of your own skull. Either way, you're suspended in a silent moment. And that moment, like all the others in your life, is defined by one thing: time. But what is it really? Is time a river you float down helplessly, a trick played by your brain, a fabric stretched across space, or a complete illusion invented so we don't collectively panic at the randomness of it all? Tonight, we're going to dig into all of it. But fair warning, you probably won't survive this philosophically, because time doesn't break easily, it shatters. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your city and local time in the comments. Let's see how many time zones we've captured in one moment. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You wake up in a world you didn't choose, and the first thing it gives you, before it gives you language, consciousness, or even the concept of self, is time. Not in some poetic, metaphorical way. You're dropped into a body that ages, into a sky that changes, into a rhythm of light and dark that insists you move. It's never still. You've been in motion since birth. Even now, as your head sinks into your pillow, your body is aging. Your atoms are vibrating. You're drifting through time whether you like it or not. Time surrounds you. The ticking wall clock, the countdown timer on the microwave, the phantom sense that your phone battery is slipping away second by second. It's a pressure cooker. You're racing deadlines, remembering birthdays, counting down vacation days. You mark your life in digits: 2025, 8:08 p.m., 2.5 children, 5-year plans, 30-minute commutes. You are, in every sense, time poison. Yet, none of these things are time itself. That's the first crack in the glass. Time is not the numbers we assign to it. The Gregorian calendar isn't time. The New Year's countdown isn't time. Your smartwatch, sorry to say, isn't time. These are just tools we've invented to measure something we don't understand. It's like trying to trap a ghost in a spreadsheet. The ancient Egyptians used water clocks, basins that dripped at a consistent rate. It was brilliant, elegant, and totally wrong, because time doesn't drip. Not really. It doesn't tick in regular intervals. It bends, it stretches, it wobbles when no one's watching. And according to some physicists, it might not even exist in any fundamental way. But more on that later. Right now, you're still stuck inside your own illusion. The one where there's a beginning, a middle, and an end. The one where you think yesterday happened and tomorrow will. But press your mind against that idea too hard and it crumbles. Because where exactly is yesterday? Show me the coordinates. Can you point to where your 5th birthday lives, or where your last breakup still echoes? Nope, all you've got is memory, and maybe a blurry photo. The harsh truth: you don't remember time, you remember events, emotions, snapshots of experience. And your brain, ever the overachiever, stitches those together like a flipbook and calls it time. That's why dreams don't feel like dreams until you wake up. It's why deja vu feels like cheating. And it's why a 10-hour workday can feel longer than your entire childhood. Time isn't consistent, not to you, not even to physics. Think about this. Time zones didn't exist until trains did. Before that, every town had its own local noon. The sun hit the highest point in the sky. Bam, that's noon. But then trains started running on schedules, and chaos erupted. You can't have London running on one clock and Bristol on another if your locomotive needs to arrive at 3:15 exactly. So in 1884, at the International Meridian Conference, yes, it was a real and deeply dramatic event. World leaders decided to slice the planet into 24 neat vertical time zones, like slicing a cosmic pie. Suddenly, time was organized, controlled, industrialized, a human invention slapped onto the curvature of Earth. Historians still argue whether the standardization of time was progress or tyranny. After all, it was mostly about coordinating trade and colonial power. But either way, that was the moment time became not just a sensation, but a system. And ever since then, you've lived inside that cage. But don't worry, it gets weirder. Because even though we now agree what time it is globally, we still have no idea what it actually is. Physicists have been trying to define it for centuries, and guess what? They still don't agree. Is it a dimension like space? A force? A property of matter? Is it flowing? Or are we just the ones moving through a static universe like a laser scanning over a DVD? Fun side note, the ancient Greeks didn't even have one word for time. They had two. Chronos, which meant sequential, ticking, boring time, the kind you see on your calendar, and kairos, the time of moments. The right time, the emotional now, the first kiss, the gut feeling, the golden hour. You've lived by both. You just didn't have the vocabulary. And even now, lying here in the dark, you're dancing between those two. The seconds crawl towards sleep, but also this moment has weight, atmosphere, kairos. There's one more thing you should know before we move on. In your brain, there's no central clock, no master timekeeper organ. Instead, you have dozens of biological rhythms. Your circadian rhythm, your ultradian cycles, your heartbeat, your gut bacteria doing their thing every 90 minutes like they're on some mysterious subway schedule. You're more like a jazz ensemble than a Swiss watch. Improv all the way down. So when people say time is a construct, they're not entirely wrong. You're not experiencing time directly. You're just interpreting signals, patching them together, narrating them to yourself in a way that makes sense. That's why trauma feels longer, why boredom stretches minutes into hours, and why a weekend getaway flashes by like a breath. Because time is not a thing you have. It's something you do. And now that we've cracked open the illusion, let's travel a bit backward, to a world before digital clocks, atomic seconds, and perpetual rush. Let's meet the first humans who dared to ask, what exactly am I counting? You wake in a place where time hasn't yet been named. No clocks, no calendars, no ticking, only the rhythm of the world itself. The sun creeps slowly over the horizon, casting long fingers of gold across stone and skin. Birds stir. Somewhere, water drips. You stretch your limbs beside a fire that's nearly gone out. Your stomach grumbles. You feel the air begin to warm. And just like that, time has passed. But you don't call it that, not yet. Before the concept of time even existed, early humans relied on what they could see and feel. The changing light, the cooling dusk, the shifting stars. If you wanted to know what part of the day it was, you looked up or around or inward. Time was less about minutes and more about moments. Hunting time, sleeping time, fiery building time, staring blankly into the void time. Sundials, the OG timepiece, didn't appear until around 1500 BCE in Egypt, though rudimentary shadow trackers were probably around even earlier. These weren't clocks as we know them, they were direction-giving sticks. You'd plant a gnomon, yes, that's the actual name, and watch the shadow slide across carved marks as the sun crawled overhead. If the shadow was long, it was early or late. If it was short, the sun was screaming at your skin and you should probably seek shade. Was it precise? Not even close, but that wasn't the point. Time wasn't something you obeyed, it was something you read. But let's rewind even further, because long before sundials, the only clock anyone trusted was the sky. Ancient Babylonians studied the stars like they were scrolling through the universe's status updates. The Sumerians divided the day into 12 parts, likely because they counted with their knuckles and finger bones. Seriously. Hold out your hand. Count the segments on your fingers using your thumb and you get 12. That's proto-math, baby. Historians still argue whether the 12-hour system came from astronomy, finger counting, or ritual practice, but it stuck. 12 hours in the day, 12 in the night. Even though, awkwardly, days aren't always 12 hours long. Whoops. Then came water clocks, clever bowls with pinholes, letting water escape at a steady drip. You'd mark the interior to track passing hours. But as you can imagine, water doesn't always behave. Temperature, humidity, and whether your uncle accidentally bumped the table could all mess with your schedule. Still, it was better than guessing based on goat shadows. Fun fact, one early water clock in ancient Greece included a built-in alarm. Around 250 BCE, the engineer Ctesibius designed a clepsydra, that's Greek for water thief, that triggered a whistle using compressed air once the water reached a certain level. Basically, the first passive-aggressive morning wake-up device. But even these early clocks weren't used like modern ones. They didn't schedule meetings or school periods. They timed speeches in the courts, religious rituals, night watches, moments that mattered. There was no expectation of standardization, no pressure to be on time. Time was something sacred. Think about Stonehenge. Yeah, that weird circle of rocks you vaguely remember from your third-grade textbook. It's not just some prehistoric art project. The stones align with the solstices, marking not hours but turning points, cosmic hinges, moments when the sun seems to pause in its endless climb. These ancient monuments weren't built to track seconds. They were built to notice change. You don't build something that massive unless time, at least big-picture time, means something. And yet, even then, people weren't obsessed with measuring every minute. There was no need to. Life was local, immediate, seasonal. You planted when it got warm. You harvested when it got chilly. You slept when it was dark and stared at the moon when your thoughts got loud. But somewhere along the line, something shifted. Blame agriculture if you want. Once humans began farming, precision mattered more. You needed to know when the rains came, when to plant, when to pray. Civilizations grew, and with them, the urge to organize. The Egyptians had solar calendars. The Mayans had calendars that tracked Venus, eclipses, and cosmic cycles that make Google Calendar look like a crayon drawing. Time was no longer just something you felt. It became something you could plan around, count, predict, and eventually control. Fast forward to the Roman Empire. You've got a relatively stable calendar, sundials on public buildings, and hours that still flex depending on the season. A Roman hour in summer lasted longer than a Roman hour in winter. Because of course it did, there were more daylight hours in summer. Makes sense, right? Except try scheduling a dentist appointment with that logic. Still, you're getting closer to a world that resembles your own. One where time slices up your day like a chef on espresso. And the shift accelerates with the invention of mechanical clocks in medieval Europe. Clocks that tick, clocks with gears, weights, and swinging escapements. Suddenly, time isn't just light and shadow, it's sound. Tick-tock. In monasteries, monks used bells to signal prayers. These mechanical clocks didn't tell you what time it was, they told you what to do, when to kneel, when to eat, when to reflect. Time became discipline, a rhythm imposed from the outside. And if you squint, you can see the modern workday emerging. By the 14th century, clock towers rise above cities, not to serve individuals but to rule the collective. Time is now a public force. You hear it echo through cobbled streets. You can't escape it. It's worth noting, mechanical clocks didn't immediately take over. For centuries, people still trusted the sun, still lived seasonally, but the gears were in motion, literally. A fringe bit of trivia. In 16th century Italy, wealthy merchants sometimes commissioned elaborate automaton clocks featuring tiny figurines, dancing devils, robed saints, even vomiting gargoyles. Because if you're going to be ruled by a machine, it might as well be dramatic. But here, where things get philosophical, none of these devices measure time itself. They measure change, movement, cycles, shifts in state. Time isn't a thing we've captured. It's a language we invented to describe what we notice. And that language, it's already shaping how you think. You say time flies, or I wasted time, or buy me some time. You treat time like a substance, a currency, a thief, a gift. And each of those metaphors sneaks into your decisions, your emotions, your sense of self. Because here's the sneaky truth. The more precisely we measure time, the more pressure we feel to use it wisely. So as you lie there, blinking up at the ceiling, consider this. The sundial never judged you. The water clock never stressed about productivity. The stars never asked you to be on time. They just changed. And you, floating in this modern soup of schedules and push notifications, are still wired to respond to rhythms older than civilization. Your body remembers them. Your blood beats to them. You are not built for seconds. You are built for sunsets. You blink and the world bends slightly. Not in some mystical, woo-woo way. In a very real, very measurable way. The kind of bend that made Einstein raise one eyebrow and rethink the entire universe. Because once upon a relatively recent time, 1905 to be exact, someone asked the question, what if time doesn't flow the same for everyone? And then promptly broke the clock. Welcome to the theory of relativity. This is where your tidy, predictable timeline gets warped like a cassette tape left in a hot car. It's also where Newton's comforting vision of the universe as a giant ticking machine quietly dissolves into cosmic soup. Let's set the scene. You're on a train or maybe a spaceship, or more realistically, sitting in traffic watching the seconds blink by on your dashboard. You see the world moving around you. But what you don't feel, what you can't feel, is that time itself is slipping, stretching, shrinking. Einstein's special relativity tells us this. Time is not absolute, it's relative to your motion. The faster you move, the slower time ticks for you compared to someone at rest. That's not science fiction, that's experimental physics. If you took off in a spaceship at near light speed, spent a year cruising around the galaxy, then came back, your friends would have aged decades. You, just a bit older, maybe a few laugh lines, a confused expression, possibly a very awkward family reunion. This isn't just a thought experiment. We've proven it with atomic clocks. In 1971, scientists flew 2 of them around the world on commercial flights, then compared them to identical clocks left on Earth. Sure enough, the flying clocks lagged behind, just a teensy bit. But enough to say, hey, time, not behaving like we thought. Historians still argue whether Einstein discovered relativity or simply realized what the math was already whispering. Either way, it shattered our understanding of time. Before this, time was a background stage, a neutral tick-tock rhythm that never changed. After Einstein, time became a player in the game, twisting, warping, reacting to speed and mass. Ah yes, mass. Because then Einstein said, wait, there's more, and gave us general relativity. It wasn't enough for time to depend on how fast you're moving. It also depends on where you are. More specifically, how close you are to something massive, like say the Earth, or a black hole, or your cat when it decides to sit directly on your chest at 3 a.m. The stronger the gravitational field, the slower time flows. That's called gravitational time dilation, and yes, it happens to you all the time, even if you don't notice. You're aging very slightly slower at sea level than someone living in the Himalayas. So technically, if you want to live longer, climb Everest. You'll gain like a fraction of a nanosecond, totally worth the frostbite. GPS satellites. They literally wouldn't work if we didn't account for time dilation. They orbit high above the Earth, far from the planet's mass and moving fast, so their internal clocks tick differently than ours down here. Engineers have to constantly adjust them so your phone doesn't send you to a field when you asked for pizza. So yeah, every time you navigate to your friend's place for game night, you're trusting that Einstein was right. The universe isn't running on one master clock. It's running on local time, personal time. Individual timelines like threads woven together but never quite aligned. There's a reason people describe relativity as trippy, because it is. It suggests that time doesn't flow, it spools, it kinks, it twists. And if you could stand outside of all motion and all gravity, which, good luck with that, you'd still have no true time to point to. Time has become subjective. It's no longer a ruler, it's a rubber band. Fringe tidbit. In 2000, scientists at the University of Colorado built a clock so accurate it loses just 1 second every 20 million years. Then they raised it by a foot, and it ticked faster. That's right. Raise a clock just 1 foot higher and boom, relativistic effects. The universe does not care about your furniture arrangement. And here's a deeply uncomfortable question. If time is relative, what does that do to your idea of now? Because relativity also shows that there's no universal present, no cosmic now that everyone can agree on. Two observers moving differently can disagree on whether two events happened at the same time and both be correct, which means the whole idea of simultaneity, it's an illusion. You might think your friend texting you from across the globe is experiencing the same present moment, but physics says, maybe not. Maybe their now is already your past, or your future. Depends on who's moving how. Kind of makes you want to unplug your phone and take a nap, huh? All this twisting of time brings us to one haunting implication. The past, present, and future might all exist simultaneously. Some interpretations of relativity lead to what's called the block universe view, where time doesn't flow, it just is. Every moment from the Big Bang to next Tuesday's dentist appointment exists like a frozen frame in a cosmic flipbook. You feel like you're moving through time, but that's just your consciousness, like a spotlight scanning one frame at a time. The film is already complete. Philosophers hate this. Some love it. Most try not to think about it too hard after midnight. And yet here you are, after midnight, thinking about it. The universe doesn't promise clarity. It just gives you rules that almost work and invites you to find the edge cases. Like black holes where time doesn't just slow, it practically stops. At the event horizon, from your perspective, time freezes. That's right, if someone fell into a black hole and you watch from a safe distance, say with popcorn and anxiety, you'd see them slow down, stretch, and then just hang there. Forever. Not falling, just frozen. Spoiler, they don't feel frozen. To them, time ticks on normally, right up until things get very, very spaghettified. But we'll get to black holes later. For now, let this settle in your mind like sediment in a glass of water. You are not experiencing the same time as anyone else. Not quite. You exist on a slightly curved, slightly personalized timeline, shaped by your speed, your altitude, your proximity to mass, and the peculiar motion of your planet through space. Time is not flat, it's not steady, and it is most definitely not fair. You move forward in time, but you do so on a trampoline made of gravity and motion. And yet somehow, you make it to work on time. You pay your bills. You set alarms and bake cakes and schedule doctor appointments for 4:30 on a Wednesday. Because despite all of this, your brain keeps pretending that time is simple. It's not. But you are doing your best to keep up. Your feet leave the ground, just a little. Maybe you're stepping into an elevator, or boarding a flight, or hiking up a hill so steep your lungs file a complaint. And whether you feel it or not, something subtle and strange is happening to you. You're aging slower. Not metaphorically, not in a poetic mountaintop enlightenment kind of way, but in literal, measurable, experimentally proven terms. Your personal clock, tucked inside every cell, every particle, every strand of your being, is ticking just a little more slowly than it was when you were closer to sea level. This is gravitational time dilation, back for an encore. Einstein's general theory of relativity, the same one we whispered about earlier, tells us something delightfully absurd. The closer you are to a source of gravity, the slower time passes for you. Gravity doesn't just pull on your body, it tugs on time itself, warps it, like a mattress being sagged by a bowling ball. If you're on the ground floor of a skyscraper and I'm on the top floor, I'm aging faster than you. Not by much, maybe a few billionths of a second over a lifetime. But still, you're technically younger. Congratulations. Hope you enjoy your microscopic immortality. This is not a thought experiment. In 2010, Physicists at the National Institute of Standards and Technology in Colorado built two of the most precise clocks in the world and placed one just 33 centimeters above the other. The higher one ticked faster. 33 centimeters, one human foot, that's all it took. So if you've ever said, "I need a vacation to feel young again," turns out you were onto something. Book a cabin in the Andes, float in the clouds, stand on your tiptoes and shave a sliver off your cosmic odometer. We tend to think of time as a universal constant, but the universe doesn't care about your feelings. It cares about curvature, altitude, speed. Where you are determines how you move through time. And it gets more extreme when you leave the surface entirely. Up in orbit, satellites experience two competing effects. Because they're moving fast, special relativity says their clocks should slow down. But because they're far from Earth's mass, general relativity says their clocks should speed up. The result? A weird mathematical compromise. Their time moves faster overall than ours. If we didn't account for this, your GPS location would be wrong by about 10 kilometers per day. You'd think you were ordering tacos from across the street, but your phone would be like, "You mean the middle of that lake, right? No thanks." So yes, your phone is smarter than you think. It's not just finding where you are. It's syncing you to Earth's warped spacetime. Little did you know your lunch order depended on general relativity being implemented correctly. Historians still argue whether Einstein ever fully grasped how unsettling his theory would become for everyday life. He certainly didn't live to see how many practical technologies now depend on his work. But the consequences are everywhere. Planes flying at high altitudes. Their clocks gain nanoseconds. Not enough to mess with your in-flight movie, but enough that pilots' watches run slightly faster than yours do down on the runway. Even your Fitbit is on borrowed time. Here's the twist. You can actually observe this difference yourself. Sort of. In 2016, scientists took atomic clocks on planes again and showed that after circling the globe, they were out of sync with ground-based clocks. And in one extremely cool experiment, a hydrogen maser clock was flown on a rocket 10,000 kilometers into the air. It confirmed relativity again. The higher you go, the faster you leave everyone else behind, just not in a way you can feel. It's quiet, inevitable, soft as erosion. And yet, this all runs counter to how you feel time. You probably think a minute is a minute, a day is a day, that your birthday arrives every 365 of those neatly wrapped bundles, but those are just averages. Your personal time is full of stretch and squish. You don't notice because your brain isn't calibrated to pick up on nanoseconds. It's too busy wondering if you left the oven on. Still, these differences add up. For astronauts who have spent significant time in orbit, like Sergei Krikalev, who racked up 803 days in space, they've literally aged less than their Earth-bound peers. By a fraction of a second, sure. But physics doesn't care how much. It only cares that it happens. Want to live forever? Easy. Just orbit the Earth for the next several million years. Or here's a fun question. What if you fell into a black hole? Let's assume for a dreamy moment that you somehow survive the tidal forces trying to turn you into cosmic spaghetti. From your perspective, you'd fall normally. But to an outside observer watching from a safe distance, your fall would slow down and eventually stop. They'd never see you cross the event horizon. You'd freeze, suspended in time. Forever falling, never reaching the center, just paused. This isn't science fiction. This is how time behaves near extreme gravity. The greater the mass, the slower time flows. So if you camped next to a black hole long enough, you could experience a few minutes while thousands of years ticked by for everyone else. That's the premise of the movie Interstellar, by the way. A mission team visits a planet near a black hole, and when they return to orbit, they've lost decades. It's dramatized, but not wrong. And yet, for all this twisting, stretching, and warping, you don't feel any of it. You walk through life assuming that time is steady, That the seconds on your watch match the ones on your friend. That the clocks in Tokyo and Toronto and Timbuktu are all ticking together in some vast cosmic rhythm. But they're not. They're each whispering their own version of now, their own slightly misaligned tempo. And you're just dancing to whatever beat your feet are planted on. Here's a quirky detail to leave you with. If you lived on a neutron star, a super-dense stellar corpse just 20 kilometers wide, time for you would tick 30% slower than for someone far away in space. 30%. You could write a novel and Earth would move on like you were procrastinating. Again. But of course, you'd also be crushed into atomic soup, so maybe not worth the writing retreat. The point is, your experience of time isn't just about memory or mood or metabolism. It's about location, about how much gravity is wrapping around your body, about how fast you're hurtling through space, whether you realize it or not. And you are hurtling, by the way. Earth spins at over 1,600 kilometers per hour at the equator. It orbits the sun at 107,000 kilometers per hour. The sun, in turn, is zooming through the Milky Way. You are always in motion, and that motion is subtly shaping your time. So next time someone asks how your day's going, you can smile and say, faster than yours. Because somewhere at the top of a mountain or the edge of orbit, someone else's clock is ticking just a little slower than yours. And your future, it's arriving at a slightly different speed than theirs. You exhale. You don't notice anything change, but in that instant, quiet, unconscious, unremarkable, your body inches forward in its private chronology. Your cells age. Your mitochondria whisper through one more metabolic cycle. If we had the right instruments, we could measure the decay of isotopes in your bones, or the shortening of your telomeres, or the shift in hormone levels in your bloodstream. You're getting older. But here's the thing, how fast? Because, inconveniently, your body doesn't run on the same clock as your calendar. You might have a birthday next week, but your biological age could tell a very different story. The question is, which version of you is real? Chronological time is what you're used to. It's what gets printed on your ID, judged by your classmates, and quietly muttered by your back every time you try to tie your shoes. It counts the years since your birth in clean, one-size-fits-all units. But your biological time, it's messy, personal, subjective, and sometimes disobedient. Two people can be born on the same day, yet one may feel decades older or younger than the other. And it's not all in their head. Scientists can measure differences in epigenetic markers, telomere length, immune system activity, even organ efficiency. Some 60-year-olds have the vascular system of someone in their 30s. Others have knees that gave up before they hit 40. So whose clock is telling the truth? Historians still argue whether ancient medicine had any concept of biological aging. Ayurvedic texts and Hippocratic traditions spoke of bodily humors and imbalances that influenced vitality, but they didn't separate age from health the way modern science tries to. To them, aging was moral, seasonal, even cosmic. Fast forward to now, and we've got aging broken into dozens of systems: cognitive, hormonal, cellular, muscular. And guess what? They don't all sync up. You could have the lung capacity of a marathoner and the memory of a distracted squirrel, or vice versa. There's even a thing called epigenetic age, which scientists calculate based on patterns of gene expression. It's like your genome's version of a weathered passport, every stamp a clue to where you've been and how rough the journey's been on you. Quirky fact: in a 2021 study, researchers found that night shift workers often had epigenetic ages that were significantly higher than their chronological ones. Turns out flipping your circadian rhythm on its head isn't just exhausting, it's aging. So if you're listening to this at 3 a.m. on your third espresso, maybe stretch. But this raises an unsettling question. If your body is aging at a different rate than your calendar says, what exactly does age even mean? You celebrate birthdays as if they measure something important, but they don't account for stress, or nutrition, or sleep, or joy. They certainly don't measure how much life you've lived. A kid might feel the stretch of a summer like it's an entire epoch, while a 45-year-old blinks and somehow it's autumn again. Time moves differently depending on who you are and how you are. Here's a fun exercise. Think of 2 years in your life. One packed with milestones, maybe a graduation, a move, a new relationship. The other, quiet, routine, blurry. Now tell me, which one felt longer? Weird, right? Because time perception doesn't always align with clock time, and that perception is deeply tied to memory. The more novel experiences you have, the more memories your brain lays down, and the longer that stretch of time feels in retrospect. It's like your brain is a scrapbooker, and time only counts if it can paste something onto the page. That's why childhood summers feel so long. Everything is new. Every bug, every bike ride, every weird smell in your neighbor's garage is a first. Your brain is in overdrive, laying down sensory data like a court stenographer. But as you age and your life settles into routine, you stop noticing. The days blur, your scrapbook pages get sparse, and suddenly a year vanishes. Biological time and psychological time, both of them ignore your calendar. And then there's your internal clock, the circadian rhythm, the 24-hour cycle ruled by light, darkness, and the hormones dancing through your bloodstream. This is the timekeeper you rarely think about, but it runs everything. When you're hungry, when you're tired, when your body repairs tissue or digests food or releases melatonin to lull you to sleep. And when it breaks, you feel it. Jet lag, insomnia, seasonal depression, that weird existential ache when you pull an all-nighter and feel like time is glitching. All of it is your circadian rhythm throwing a tantrum. Here's something wild. Your circadian rhythm isn't exactly 24 hours. It's closer to 24.2, which means your body is always a little off, constantly adjusting itself to match the actual day. You're living in a world that has to manually sync your internal time to Earth time, like a smartwatch needing a Bluetooth connection. That syncing isn't perfect. People with non-24-hour sleep-wake disorder, often blind individuals, whose bodies don't receive light cues, live on their own time, free from the tyranny of sunrise. It's like their biology refuses to submit to the world's shared illusion. And we haven't even talked about how time feels when you're in love, or afraid, or bored out of your mind. A moment of danger, time slows to molasses. Your brain cranks up its attention, pulling in detail after detail, laying down memories in high resolution. That's why traumatic events seem to stretch in memory. Your body wasn't just scared, it was hyper-aware. Your internal time perception sped up, even as external time marched on at the same rate. Or so you think. Because now we know that subjective time is as malleable as clay. Even your heartbeat plays a role. Studies show that when your heart rate slows, like during meditation or deep sleep, your sense of time can slow with it. You sink into the moment, lose your place in the sequence, float. Ever stared at the ceiling at 3 a.m. and thought, has it been 10 minutes or an hour? That's your internal clocks falling out of sync, creating a little temporal vertigo. And here's a haunting little detail. Your brain processes events in tiny windows called perceptual moments, lasting about 2 to 3 seconds. That's the chunk size of your now. It means your present is actually a blend of the very recent past, smoothed out into what feels like a continuous moment. Kind of like watching a flipbook and calling it a movie. So what is real time for you? The clock on the wall, the pressure in your arteries, the amount of wear on your DNA, the rhythm of your sleep, the timestamp on your social media memories. The answer, of course, is yes. They're all real, and none of them are the whole picture. You are an orchestra of clocks, biological, psychological, atomic, and none of them play exactly in sync. But together, they create the strange symphony that is your life. So next time you feel like time is slipping away, remember, it always has been. but you wonderfully have been slipping right alongside it, not losing the race, just dancing with it. You drop a scoop of ice cream on a hot sidewalk. It melts instantly, white rivers carving sticky trails between the cracks. You sigh, maybe curse gently under your breath, but the truth is, you already knew this would happen. Things fall apart. That's what they do. And just like that, you've encountered time's favorite trick, the arrow. Not a real arrow, no fletching, no sharp point, no bowstring humming with tension. This arrow is invisible. It has no feathers, no direction marker, but you can feel it always. It's the reason why things break but never unbreak. Why ice melts but doesn't spontaneously reform. Why you remember the past but not the future. It's called the arrow of time, and it's rude. In physics, the arrow of time is a term we use to describe the one-way direction we experience reality. Things go forward, they age, they decay, they progress. Time only marches in one direction, except, according to most of the laws of physics, it doesn't. That's right, almost all of the fundamental equations that govern our universe are time-symmetric. They don't care if you run them backward or forward. Gravity works both ways. So does electromagnetism. Even the math of quantum mechanics doesn't insist on a particular direction. So, what's forcing everything to move on? Enter entropy, the one law that ruins everything, literally. The second law of thermodynamics says that in any closed system, entropy, aka disorder, must increase over time. Neat things become messy. Organized things unravel. Cold things heat up. Your bedroom, your hard drive, your carefully alphabetized spice rack, they're all doomed. And entropy is where the arrow of time gets its teeth, because entropy doesn't go backward. Ice doesn't reassemble. Burnt toast doesn't unburn. A broken glass doesn't hop back together in reverse, unless you're watching a video on rewind and lying to yourself. This gives time a direction, one tied not to physics but to probability. There are more ways for things to be disordered than ordered. That's it. That's the whole secret. Historians still argue whether the concept of entropy was inevitable once steam engines appeared and early scientists started measuring heat. Some say it emerged naturally from observing thermodynamics in action. Others suggest it was a philosophical need to give time an anchor, something that grounded it in the physical world, not just our perception. Either way, entropy turned time into a one-way ticket. You can't unpop popcorn. You can't reverse rust. You can't unspill milk, unless you're a toddler in a very optimistic commercial. But here's the twist. If entropy is what gives time direction, then what if we lived in a universe where entropy decreased? That's a question physicists love to ask at parties, usually right before getting uninvited. The idea is that maybe, somewhere, sometime, there's a version of the universe where entropy moves the other way, where things become more ordered, where clocks still tick forward but memories form in reverse, where cause follows effect backwards, a reality where time's arrow points the other way. The problem, we've never seen such a thing. And our own universe started with an absurdly low entropy state, the Big Bang. A hyper-organized moment of extreme simplicity. Since then, it's all been chaos and expansion, mess and motion. Every moment since has been a tumble toward more disorder. Which leads to one of the big philosophical debates about time. Is the arrow of time just a local feature of our universe? Or is it baked into the structure of all reality? We don't know, and worse, some cosmologists argue that if the universe is infinite, there might be regions where entropy flows differently. Maybe even places where now is backward from our perspective, but we'd never see them. They're too far away, too weird, and probably too smug about it. Back here on Earth, you feel the arrow of time in your bones, in every irreversible thing, teeth wearing down, paint peeling, food spoiling, deadlines passing, people aging. Time feels real because things fall apart. Here's a fun side note. Entropy isn't just about physical systems. It shows up in information theory too. That's right, your brain, your memory, your ability to store and recall facts, they all follow entropy rules. The more you try to compress information, the more order you impose, and the harder it becomes to keep it pristine. Your memories, as it turns out, degrade, not just because you forget them, but because they change. Every time you remember something, your brain rewrites it, adds new associations, warps the edges. You're not recalling the past, you're reconstructing it, over and over again. So even internally, time has an arrow. You remember what happened, but you don't remember what didn't. You remember your wedding, but not the one you called off. You remember the day your dog barked at the mailman, but not all the times they didn't. The past leaves fingerprints, the future doesn't. And yet some scientists are still asking, does the arrow of time emerge from entropy, or is it something deeper? Some quantum theories suggest the arrow isn't fundamental at all, but an emergent property of how observers like you collapse probabilities into single outcomes. That may be the very act of being conscious, of witnessing reality, gives time its direction. Which would mean time flows forward because you are watching. If that's true, then time isn't just a backdrop. It's a process unfolding with you in the middle. You're not moving through time. Time is blooming around you, like ripples in a pond, expanding outward from the pebble of your perception. Now let's turn the dial on entropy just a little further, into the truly weird. There's a hypothesis in cosmology called the heat death of the universe. Sounds cozy, doesn't it? This is where all usable energy is spent. Entropy reaches maximum. No stars, no light, no structure, no complexity, just a vast, dark stillness. The arrow of time doesn't disappear, it just stops mattering because nothing changes. There's no low entropy state to move away from anymore. It's all uniform, gray, quiet. In a way, it's the final punctuation mark on time's sentence. You don't remember the future because you're built to survive entropy, to take in heat, convert it, and keep moving. But the universe is writing a very long story, and the ending is still up for debate. Some say it'll end in cold silence, others in a big bounce, a reverse crunch back toward a singularity. Some theorists even flirt with the idea that time itself might reverse, like a VHS tape reaching its end and starting again. Play backward, unwind. Which begs the question, if time can go backward, would you even know? If your memories rewound with you, if your consciousness slid in reverse, if the arrow of time flipped mid-flight, like a weather vane in a storm, and all of reality politely played along. It's a comforting illusion that time moves one way, but maybe it's just the only direction we've ever seen. The arrow of time is not a rule, it's a pattern. And you are a walking, talking piece of entropy, a little order trying to hold itself together day after day against the rising tide of chaos. And somehow, despite everything, you've made it this far. Your calendar is a liar. Not maliciously, not with cruel intent, but it's been deceiving you for your entire life, hiding the messy truth under clean boxes, numbered grids, and color-coded months. You flip a page and boom, time has progressed. Neat, tidy, obedient. But time has never been tidy. And calendars, oh, they've been a chaotic mess since the moment someone decided that counting moon cycles would be a good idea. You wake one morning in a world without digital clocks, no phone alarms, no work schedule reminders, just the slow wheel of the sky above you and the suspicious feeling that maybe it's planting season again. You're an ancient Sumerian farmer, or maybe an early Egyptian scribe, staring up at the stars, trying to figure out if your boss will yell at you for being late to whatever it is you're supposed to do today. Because before the mechanical clock, there was the calendar, and hoo boy, if you think the current system is confusing, wait until you hear what humans went through to make Wednesday a thing. Early calendars were based on two things, the sun and the moon. Logical choices, right? The sun defines the day, the moon offers a nice, repetitive cycle to help track time. But guess what? The lunar month is about 29.5 days, and 12 of those gives you just 354 days. The solar year is about 365.25 days. That gap, that's a problem. A problem that gave generations of timekeepers headaches and whole civilizations many identity crises. Enter calendar reform. Take the Egyptians, they had a pretty chill 12-month calendar, each month with 30 days. But that only gave them 360 days a year. To catch up, they added 5 bonus days at the end. Festival time, time out of time, literal party days, no work, just vibes. Honestly, not a bad idea. Then the Babylonians got involved, bringing lunar calendars to the mix, and things got slippery. Imagine being a priest astronomer trying to calculate new moons without a telescope, while local farmers yell at you because the barley harvest is late again. Stressful. Now jump to the Romans. Oh, the Romans. They took timekeeping chaos to the next level. They inherited a lunar calendar from the Greeks, but they couldn't quite figure out how to make it sync with the solar year. So they did what any imperial power might do, they started making it political. Literally. Roman priests were in charge of announcing when months began, which meant they could stretch or shorten months depending on their agendas. Need more time before elections? Add a day. Want to shorten someone's term in office? Snip a few days off the end. Time became negotiable. Historians still argue whether this calendar corruption was a clever tool or a bureaucratic nightmare. But either way, it was so bad that by 46 BCE, winter was creeping into autumn, and nobody could figure out what day it actually was. Enter Julius Caesar. He said, "Enough," and hired a smart guy named Sosigenes to fix it. The result? The Julian calendar, based on the solar year with 365 days and a leap year every 4. It was simple, clean, and almost perfect. Almost. Because 365.25 days isn't quite right. The solar year is actually a bit shorter, roughly 365.2422 days. And that tiny error, it adds up. By the 1500s, the calendar was off by about 10 whole days. Easter, which was supposed to mark the spring equinox, was drifting into summer. The church was, understandably, very annoyed. Cue Pope Gregory XIII, who unleashed the Gregorian calendar upon the world in 1582. 10 days were dropped. October 4th was followed immediately by October 15th. People freaked out. Some thought they'd lost part of their lives. Others claimed the church stole their birthdays. Fun fringe fact: not everyone adopted the Gregorian calendar at the same time. Protestant countries resisted, thinking it was a Catholic plot. Britain didn't switch until 1752. Russia held out until 1918. That means for centuries, there were 2 calendars floating around Europe, and international correspondence was a hot mess. Imagine planning a meeting in both calendars. I'll see you on the 14th. Which 14th? Exactly. And speaking of wild calendar systems, did you know the French Revolution introduced an entirely new one? In 1793, France tried to wipe away all traces of monarchy and religion, including the calendar. They introduced the French Republican calendar with 10-day weeks, so long, weekends, 30-day months, and 12 months named after weather, crops, and seasons, like Brumaire foggy, Fructidor fruitful, and Nivos snowy. They even had decimal time, 10 hours in a day, 100 minutes per hour, because apparently no one was suffering enough. It lasted only about 12 years before Napoleon said, "This is dumb," and went back to Gregorian time. But it left its mark, literally. The calendar reset to year I of the new republic, as if they were saying, "We're starting time over from scratch." Bold move. Of course, the revolution wasn't the only reason people have rewritten time. Different cultures throughout history have adopted totally different rhythms. The Islamic calendar is purely lunar, shifting through the solar year over decades. The Chinese calendar is lunisolar, adding intercalary months to stay in sync. The Hebrew calendar, same, complex, beautiful, a kind of interwoven cosmic math. Meanwhile, the Mayans, they had multiple calendars, one for sacred days, one for agricultural cycles, and one big one, the long count calendar that famously ended in 2012, sparking doomsday panic. Spoiler, we're still here, and so is time. So here's the point. Time, as we measure it, is a cultural construction. Your 9-to-5 workday, arbitrary, your weekend, a social agreement, leap years, a mathematical bandage. The very months you write in your planner, January, February, March, are echoes of gods and emperors. July is for Julius, August for Augustus. March is for Mars, the Roman god of war. September through December, named for numbers that no longer match their place. Sept equals 7, but it's the 9th month. Oops. Your calendar is a story, a narrative, a political tool, a peace treaty with the sky. And like all stories, it's been revised many times by people who had no idea you'd be scrolling through it centuries later on a tiny glowing rectangle. You think you're living in August, but really you're floating in a sea of historical compromise, cultural negotiation, astronomical math, and sheer human stubbornness. And even now, that calendar has gaps. Leap seconds are still occasionally added to account for Earth's wobble. Time doesn't behave perfectly, and our systems still scramble to keep up. Some scientists suggest ditching leap seconds altogether. Just let time drift and adjust later. It's a reminder we're still chasing time, still guessing, still trying to pin it down. But time isn't on your calendar. It's in the tilt of Earth's axis, the shape of the moon, the flicker of stars, the hunger in your belly, the shift of light across your floor. Your calendar is useful, but it's not truth. It's a map. And time is still out there untamed. You fall mentally, anyway, into the microscopic, jittering world beneath your skin. Atoms buzz, molecules stretch and snap, particles blink in and out of certainty like shy houseguests. And time doesn't work here the way you expect. In the quantum realm, the one place you'd really like some order, time barely bothers to show up. It's easy to forget, lying on your comfortable mattress, wrapped in a blanket shaped like a tortilla, that you're made of particles. That everything around you, this screen, the air, your favorite hoodie, isn't solid, not really. It's mostly emptiness dressed up in probability. And at that level, time gets fuzzy. In classical physics, the world of falling apples and levers and roller coasters, time marches forward, predictable and mechanical. But in quantum mechanics, not so much. At the particle level, reality doesn't unfold like a well-organized movie. It stutters, it jitters. Events happen without clear sequence. Some seem to reverse, others defy time altogether. There's no definitive before and after, just probabilities. Take the famous double-slit experiment. Fire a single particle at a barrier with 2 slits, and it behaves like a wave interfering with itself, as if it went through both slits at the same time. But the moment you try to observe which slit it goes through, the interference disappears. The particle chooses a path, which leads to one of the wildest interpretations of quantum theory, that the act of measurement collapses a cloud of possible futures into one. Not only does time refuse to behave, it seems to wait for you to look. And here where it gets worse. Some quantum experiments suggest that actions in the present can influence the past. Yes, you heard that correctly. The delayed choice quantum eraser experiment is the kind of thing that makes physicists stare into the middle distance and mutter about needing stronger coffee. In this setup, a particle's past behavior seems to change based on a decision made after it passed through a barrier. It's as if the universe rewrote history on the fly to match the present. Historians still argue whether these results say something real about time, or just expose how little we understand the measurement process. But either way, the quantum realm doesn't play by the rules of everyday cause and effect. Time there isn't linear. It's not even particularly directional. In some formulations of quantum gravity, and yes, there are multiple because of course there are, Time doesn't exist as a fundamental part of reality at all. It's an emergent property, something that only makes sense when many particles come together, like a murmur of starlings or a traffic jam. Let's say that again slowly. Time, according to some physicists, is not a basic feature of the universe. It only appears when enough stuff is interacting. If the cosmos were empty, no time, no ticking, no flow. Just silence. Now zoom in on your particles again. You're mostly hydrogen, carbon, oxygen. All those atoms obey quantum rules. They vibrate, share electrons, get entangled. But in your everyday life, you don't experience quantum fuzz. You get seconds, minutes, hours, one foot in front of the other, clean sequences. That's because quantum uncertainty averages out at scale. It's like trying to predict a riot by tracking individual ants. You won't get far, but zoom out and the crowd becomes manageable. A pattern emerges. That pattern is what you call time. But there are cracks in the surface. Take quantum tunneling. That's when a particle appears to teleport through a barrier it technically doesn't have the energy to cross. It shouldn't be able to get through, but it does. It just shows up on the other side as if the laws of physics briefly sighed and said, "Fine." Tunneling is used in everything from scanning electron microscopes to nuclear fusion inside the sun. And guess what? In some scenarios, it appears to happen faster than light, which brings up another uncomfortable possibility. Time might not just be weird, it might be optional. Because if you can bypass distance without time, then what does that say about your understanding of sequence, of before and after, of cause and effect? Quirky side note, quantum entanglement is another middle finger to classical time. When two particles become entangled, they share a state, no matter how far apart they are. Change one and the other changes instantly. No time delay, no signal sent. Einstein called it spooky action at a distance, which is physicists speak for, "I do not like this." And sure, no usable information travels faster than light. Entanglement can't be used to send messages to the past, but it still hints at something wild beneath the surface, some deep, hidden layer of reality where time and space as you know them aren't real. Let's take a breath, or at least simulate one. Because this next bit requires a calm head and an open mind. There's a theory floating out there, casually proposed by Nobel Prize-winning physicist Julian Barber, that time doesn't flow at all. Instead, the universe exists as a series of nows, distinct, self-contained configurations of reality. Every moment you've lived, every breath, blink, and awkward wave is one such configuration. They don't evolve, they exist, like pages in a book or frames on a reel of film. Your consciousness moves between them, creating the illusion of passage. But the past isn't behind you, it's beside you, already complete. You aren't moving through time. You're flickering through a collection of possibilities. And here's the kicker. Barber suggests that all these nows exist simultaneously. That every version of you, sleeping, dancing, sobbing into a pillow, dramatically ordering a croissant at 3 a.m., is as real as this one, frozen, eternal, but only one is being experienced now. Sound familiar? It echoes some interpretations of quantum mechanics, especially the many worlds interpretation, which says every quantum event branches reality. Every choice, every flip of a particle's spin spawns a new universe. Your path through those universes is your timeline, but again, the other branches still exist. So here we are, a human brain built to expect cause and effect, floating in a sea of probabilities, pretending that time is solid. And we still go to work at 9 a.m. every day. Brave. You wake each morning into a world that feels continuous. You drink coffee, you lose your keys, you argue with a printer. It all seems linear, logical. But beneath it, a quantum swirl, a dance of moments, a sequence that might not be a sequence at all. It's enough to make your neurons short-circuit. And yet you persist. a being of atoms surfing a wave of nows, thinking in paragraphs, loving in arcs, aging in spirals. The particles don't care, but somehow you do. You snap awake, mentally not physically, into what feels like now. It's slippery though, this now. You're here, sure, but how long is it? How wide? Can you measure it? Can you bottle it, hold it, put it in your pocket and carry it through the rest of the day like a charm against time's erosion? You've been told that you live in the present, that your awareness exists in this exact moment, perched on the razor-thin line between past and future. But science has some deeply uncomfortable news for you. The present isn't what you think it is. In fact, it may not exist at all. Let's start with your brain, the place where time is supposed to live, right? Well, your brain doesn't process events instantly. Everything you experience is delayed by a tiny but crucial amount of time. When light hits your retina, it takes roughly 80 milliseconds before your brain registers that something has happened. Sounds, touch, all with their own slight lag. So that moment when you say, "Now I see it," you're actually seeing a smudged version of what already was. Even worse, your brain doesn't treat those signals separately. It synchronizes them. It waits just long enough to gather data from all your senses, then presents you with a single unified experience. Now. Which means that your present moment is a composite, stitched together from events that didn't happen at the same time. Kind of like how sitcoms add canned laughter after a punchline. It's not real time, it's edited. There's even a term for this, the specious present. It's the duration of the mental now you perceive. And it's not a point, it's a span. Neuroscientists estimate it lasts about 2 to 3 seconds. That's how long your brain holds onto sensory data before releasing it into memory's abyss. 2 to 3 seconds. That's your now. Everything else, either memory or prediction. And yet it feels seamless. You don't experience life as a staggered slideshow. You get smooth, flowing continuity. It's one of your brain's greatest tricks, pretending you're living in real time while constantly buffering, like a cosmic YouTube video on bad Wi-Fi. Historians still argue whether early philosophers sensed this illusion. St. Augustine famously puzzled over time in the 4th century, writing, "What then is time? If no one asks me, I know. If I want to explain it to a questioner, I do not know." Same, Augustine, same. Modern science has only deepened the mystery. Because the more we study the brain, the more it seems like consciousness lags behind reality. In one famous experiment, neuroscientist Benjamin Libet showed that your brain starts preparing for movement before you consciously decide to move. That is, the choice to move your hand appears after the neural activity that makes it happen. Your decisions might be arriving after the action starts. Your present might be arriving after reality. Sleep well. But don't worry, it gets weirder. There's evidence that your brain predicts the present. It constantly generates models of what should be happening based on memory and context. So what you perceive isn't the raw data, it's a guess that's then corrected, frame by frame. If you've ever watched a badly dubbed movie, you know what it feels like when the guess is off. In normal conditions, though, your brain is shockingly good at this predictive dance. That's why you can catch a baseball, why you can read lips, why you don't constantly trip over your own feet. You're anticipating the next sliver of time before it even happens. And when the prediction fails, you feel it. That jolt when a horror movie jump scare lands just slightly too fast. That weird dislocation during déjà vu. That moment when a song you know skips one beat and your whole body flinches. Those are cracks in the present. Open debates still swirl in neuroscience circles about how exactly consciousness navigates time. Is it a flowing river or a constructed illusion? Are you riding a moving spotlight over a frozen landscape of events? Or is the present a tiny, flickering glitch, just enough continuity to keep you functioning? Let's bring in the philosophers again, shall we? There's a position called presentism, which says only the present is real. The past has vanished. The future hasn't happened. Only this moment right now exists. If you've ever stared into your cereal bowl and whispered, "This is all there is," you've practiced presentism. But then there's eternalism, which laughs politely in the background. Eternalism says the past, present, and future all exist, equally and unchangingly. That time is like space, a landscape you don't move through, but instead exist within entirely. That your 5th birthday is as real as the sentence you're reading now. You just aren't currently conscious of it. It's a deeply unnerving view, but it matches up nicely with Einstein's theories. If time is just another dimension, then why should now be special? Here's a mind-drinkling analogy. Imagine a DVD of your life. Every frame exists on the disc. The DVD player, your consciousness, reads those frames one at a time. You think the story is unfolding, but really it's already there, start to finish. And if that's true, then this moment, this quiet, dark, sleepy second is frozen in cosmic amber. It won't fade. It won't change. It will always be here, nestled between the moment before and the one after. You just won't always be watching it. There's one more unsettling detail about the present, courtesy of physics. Different observers don't agree on what now is. Due to relativity, two people moving at different speeds or in different gravitational fields can disagree on whether two events happened at the same time. Simultaneity isn't universal. So even the idea of a shared now is just convenient fiction. We agree on a now because it's useful, because we need to schedule lunch, because we like to say happy birthday on the right day, because it's awkward to arrive at a movie 45 minutes late and insist it was now in your frame of reference. But beneath all that coordination, time is slippery, contextual, relative. And the present. The present is an editing room, a stitched-together story, a smooth hallucination played across your mental projector, carefully curated by a brain trying to keep you from screaming. So the next time you feel like time's flying or dragging or dissolving completely, remember, that's not a flaw in your system. That is the system. You are a creature of delay, a being living slightly behind the beat, dancing in a spotlight that's always just a few milliseconds late, but never quite off. And in this soft, curated moment we call now, you're here. Wherever that is. You pause, on purpose this time, and ask yourself the question no one really wants to face. What if time stopped? Not metaphorically, not today is dragging kind of stopped. We're talking about a full, physics-defying, universal halt. No ticking clocks, no heartbeats, no molecules vibrating or planets spinning. Just a sudden cosmic freeze, a universe caught in mid-breath. And the weirdest part, you might not notice. Let's entertain this horror comfort scenario for a moment. Suppose time, whatever that actually is, simply ceased to move. What would that look like? Well, nothing. And that's not a poetic answer, it's a literal one. Because without time, there's no change, no movement, no light traveling from one point to another, no synapses firing, no thoughts forming. You wouldn't be frozen in time like an action figure in a paused movie. You'd be erased from experience. The moment wouldn't be paused, it would be lost in the absence of before or after. Time stopping isn't like holding your breath. It's like erasing the very idea of breath. Here's the unsettling detail. Your awareness depends on time. Every conscious thought you have is stretched across milliseconds. To feel joy, pain, confusion, or that fleeting urge to check your phone again, you need time to pass. Without it, there's no you, no next, just static. Which leads to the most paradoxical part. If time froze, you'd have no way of knowing, because knowing takes time. Even the thought time has stopped requires motion inside your head. So if time ever did come to a halt, you wouldn't feel it. You'd simply never reach that realization. Still, let's poke the physics bear a little harder. What is it that could stop time? According to current physics, time is bound up with space, literally woven into a thing called space-time. It's not an independent backdrop, it's part of the structure of the universe. For time to stop, space-time would have to break, fold, or vanish entirely. And while that sounds dramatic, it's not entirely science fiction. At the heart of a black hole, for instance, time appears to slow to a crawl from the perspective of an outside observer. If you fell toward the event horizon, someone watching from a distance would see you stretch and freeze in place, forever falling, never arriving. But from your perspective, things would keep moving. You'd cross the event horizon just fine, right up until gravity turns you into spaghetti. So while time appears to stop for the viewer, it doesn't for the participant. This distinction is important, because the illusion of frozen time isn't the same as time actually stopping. And then there's the Big Freeze, a popular end-of-the-universe theory. Picture it, the cosmos keeps expanding. Galaxies drift further apart, stars burn out, black holes evaporate, entropy peaks. Everything spreads into a cold, uniform fog of inert particles. In that final state, nothing changes. No energy left to fuel reactions. No structure, no movement. It's not time stopping per se, it's time becoming irrelevant. In a heat-dead universe, every moment is the same, like a clock that still exists but whose hands never move. A museum of frozen possibilities. Historians and cosmologists still argue whether this constitutes an actual end of time or just the end of meaningful time. Does time require change to exist? Or does it continue, empty and unnoticed, long after everything worth noticing is gone? There's also a more cheerful thought. Time doesn't stop, we do. There's an idea in physics that time is emergent. It only makes sense from the perspective of beings who can observe and remember. If there's no one left to track time or care about it, does it still unfold? Or does the cosmic clock require a conscious audience? It's the tree falling in a forest question, but with black holes and entropy. Let's shift gears and go quantum again. Some interpretations of quantum mechanics don't even need time. The Wheeler-DeWitt equation, which attempts to combine quantum physics and gravity, doesn't include time as a variable at all. It describes a timeless universe. No flowing river, no ticking clock, just a vast, static configuration of probabilities. From this angle, time isn't something that flows. It's something we experience when we're inside the system, observing changes. Step outside the system, good luck, and the whole thing looks frozen, timeless, unfolded. It's like you're inside a novel and think the story is progressing, but someone outside the book can see all the pages at once. A universe without time, it might already be that way. Your experience of motion, of choice, of past and future, it's a story your brain is telling itself. A very convincing story, with just enough delay, memory, and prediction to make it feel real. But take away any one of those ingredients, and the whole illusion collapses. Let's try a thought experiment. Say some malicious trickster god hits pause on time. Everything freezes, molecules stop vibrating, light halts mid-bounce, electrons stop spinning. In this timeless limbo, what happens to you? Answer: nothing. You don't notice. You don't exist in a meaningful sense, not until the play button is pressed again. Time isn't just a setting on your environment. It's the very medium through which existence unfolds. Without it, your story has no pages. Quirky side note: in some sci-fi stories, time stops selectively. One person or object is immune, moving through a frozen world like a ghost in a paused movie. But that requires bending or breaking all known laws of physics, because motion through space is motion through time. To move at all, you need time. No loophole, no cheat code, just silence. So if time ever stopped, it wouldn't be dramatic. No sudden stillness, no long echoing clock tick, no final thought. It would be a total erasure of experience. The end of the sentence without a period. But let's end on a slightly warmer note. Time may never actually stop, not globally, not permanently. Some cosmological models suggest the universe could loop, bounce, or reboot itself, spawning new timelines, new flows, new versions of now. You might even get a rerun. And if time does ever pause, let's hope you're frozen mid-laugh, or mid-dance, or mid-spoonful of the best soup you've ever tasted. Because that moment, unnoticed, unmeasured, unrepeatable, might just be the closest thing you have to eternity. You drift further now, past clocks and calendars and clever human metaphors, until you reach a place where time itself begins to blur, not just in perception, not just in theory, but in the very architecture of the cosmos. Here's the question no one quite knows how to answer. Does the universe even need time at all? We've been talking about time as if it's a central character in this story, as if the universe wakes up every morning, sips its dark matter latte, and gets to work ticking forward. But what if time isn't the script? What if it's just the lighting crew? Let's zoom way out, past the galaxies, past the filaments and voids, past the remnants of the Big Bang still crackling faintly across the sky in microwave whispers. From that perspective, there's no ticking, no motion, just geometry. In theoretical physics, particularly in certain models of quantum gravity and cosmology, time doesn't appear as a fundamental property of the universe. It's not in the equations. There's space, there's curvature, there's energy and information. But time is suspiciously absent. Take the Wheeler-DeWitt equation, which we brushed against before. It tries to unite general relativity, where time is bendable, with quantum mechanics, where time is a polite suggestion. But in this equation, arguably one of the most important in theoretical physics, there's no time variable. That's right, the math doesn't need time. So naturally, physicists panic a little. They start asking awkward questions like, if time isn't in the equation, then how does anything happen? How do we explain change? Where did I leave my coffee? The answer some of them propose is that change is real, but time is not. What we call time might simply be our experience of shifting relationships between things. The configurations of matter and energy change, and we interpret that as movement through time. Think of it like a flipbook. Each page is a complete static image, but when you flip them quickly, you see motion. You feel time, but really, nothing is moving. It's your perception that's doing the heavy lifting. Now replace the flipbook with the entire universe. Some physicists argue that all of existence is a collection of static snapshots of reality, each one timeless on its own, but strung together by our consciousness into something that feels like a flowing timeline. And here, where things get uncomfortable. Because if the universe doesn't require time, what does that say about you? About your memories, your goals, your childhood, your deeply embarrassing high school poetry. If the universe is a timeless tapestry of all possible configurations, then your entire life, every single moment, is already stitched in. Not happening, just there. No progress, no motion, just presence. It's called the block universe model, and we'll spend more time with it later. But for now, just know that from the perspective of some physicists, nothing is changing. You are not moving. You are simply a part of the structure, an embedded pattern within the grand, unchanging whole. But wait, you say, I clearly experience time. Yes, you do. But so do characters in a novel. They feel time. They change, grow, remember. Yet from the author's point of view, they're ink on a page, complete, fixed, readable in any order. Fringe fact: in certain approaches to quantum gravity, time emerges only when you look at the system. It's not a fundamental part of reality, but a byproduct of interaction. Time, in this view, is relational. It only makes sense when one part of the universe compares itself to another. Like two people in a room saying, it's later now than it was before. But if there's only one person, or no one, then what even is before? This leads to the deeply weird idea that time doesn't exist without observers. In a lonely, observation-free universe, say shortly after the Big Bang, before stars and life and reality TV, time might not have existed at all. Just an undifferentiated soup of potential. No sequence, no clock, no passage. Just is. Historians still argue whether ancient concepts of cyclical time anticipated this view. Many cultures, Hindu, Mayan, Stoic, imagined the universe as an eternal cycle. Time wasn't linear, it was circular, repeating, collapsing and restarting. In some ways, this might be closer to modern cosmology than the Judeo-Christian linear timeline that dominates Western thinking. Let's turn to black holes again, our favorite cosmic chaos machines. Near a black hole's event horizon, time stretches infinitely. From the outside, objects falling in appear to freeze. Not slow down, freeze. A clock on the edge of a black hole's event horizon stops ticking from your point of view. You'd never see it move again. That part of the universe is now permanently paused. To someone crossing the event horizon, time continues normally until it doesn't. But from the outside, they become a frozen statue on the edge of oblivion, neither alive nor dead, neither past nor future, just stuck. This isn't just metaphor, it's measurable. We've seen light get redshifted near massive objects. We've watched time stretch under gravity. And if time can stretch, maybe it can vanish. There's another idea floating around in physics, conformal cyclic cosmology, proposed by Roger Penrose. He suggests the universe doesn't just expand and die, it resets. After a trillion years of entropy spreading, particles becoming indistinguishable, and black holes evaporating, the universe becomes so structureless that time ceases to have meaning. And then poof, a new Big Bang. The loss of all temporal markers becomes the birth of a new temporal frame. Time dies, and from its corpse, time is born again. It's basically the Doctor Who version of cosmology. So if time can emerge and disappear, and maybe isn't even real to begin with, what does that mean for you, lying there in your pajamas trying to fall asleep? It means that your experience of time is a layer, a lens, a useful fiction. You live by clocks, wake to alarms, eat lunch at noon, dread Mondays, plan for next year. But beneath it all, the universe isn't ticking, it's unfolding, if it's even doing that. Your thoughts feel like a river, but maybe they're raindrops scattered across a windshield, each complete, each isolated, and the flow, that's just how your mind arranges them. It's comforting to think the universe runs like a machine, a clockwork cosmos, but if you ask the deepest theories we have, they whisper something stranger. There is no cosmic clock. There is only form, relation, pattern. And you, fleeting, shimmering, questioning, are part of that pattern. Not moving through time, but being time in motion. You close your eyes and picture it yourself, stepping into a time machine. Not a metaphorical one. A proper, glowy, buzzing, chrome and blinking lights contraption, complete with a lever labeled past, and a big red button that just says G.O. The fantasy is delicious. Travel backward, fix a mistake, say the thing you didn't say, avoid that haircut, buy early stock in the internet. Or travel forward, see what becomes of Earth, of your descendants, of the awkward AI running your coffee maker. See the far future unspool in shimmering light. But here's the twist. Time travel isn't just science fiction anymore. Real physics, actual, hard-nosed, sober scientists have been peeking at time travel from the side for years. Not because they think it's likely necessarily, but because the equations don't forbid it. And that's where things get deeply weird. Let's start simple. Time travel to the future is real. Proven, happens constantly, not in dramatic beam me to 2045 ways, but through relativity. Remember all that business with clocks ticking slower near gravity and motion? That's time travel. You fly through space at high speed, you experience less time than the people you left behind. Congratulations, you've traveled to the future. Not a loophole, not a theory, a fact. Astronauts on the ISS age slightly less than people on Earth. Not by much milliseconds, but the difference is real. Their clocks fall behind. Their timelines skew. They're time travelers, just without the dramatic lighting. But time travel to the past. That's where things start boiling over. The laws of physics, particularly Einstein's general relativity, allow for certain solutions to the equations that imply backward travel. These involve exotic structures like closed time-like curves, or CTCs, which are basically loops in spacetime. If you followed one, you'd return to the point you started, only earlier. Let's take a famous example, the Gödel metric, developed by logician Kurt Gödel in 1949. He discovered a rotating universe solution to Einstein's field equations that permits time loops. If you took the right path through this spinning spacetime, you could arrive at your own past. Historians still argue whether Gödel meant it as a serious proposal or a philosophical jab at the idea of time being real in any strict sense. But the math? Solid, beautiful even, and terrifying. Then there's the Tipler cylinder, an infinitely long spinning tube of dense matter. If you orbited it at the right speed and angle, you trace a closed time-like curve and wind up in the past. Sounds doable, right? Just build an infinite cylinder. Easy. More practically, though still very much in the speculative zone, physicist Kip Thorne and his colleagues once explored the possibility of using wormholes for time travel. A wormhole is a theoretical tunnel through spacetime, connecting two points that could be light years or years apart. If you took one end of the wormhole and accelerated it, say, by dragging it around near a black hole or spaceship at near light speed, then brought it back, you'd create a time offset between the two mouths. Step through one, and you emerge before you entered. Boom, time machine. Of course, this requires exotic matter with negative energy density, which might exist, but we can't really make it. A stable wormhole, which may collapse if you so much as sneeze near it. Technology that might as well be magic. Still, it's not impossible, just extremely inconvenient. And of course, the universe might just have built-in mechanisms to prevent time travel paradoxes. The most famous of which is the grandfather paradox. You travel back in time and accidentally prevent your grandfather from meeting your grandmother, which means you're never born, which means you can't go back in time, which means, But quantum theory offers a strange loophole. Some physicists believe that quantum events, when combined with CTCs, resolve paradoxes automatically. A time traveler could go back, but would be unable to make any changes that result in contradiction. The universe self-corrects. Your actions are part of the loop, not a deviation from it. Others suggest many worlds interpretation handles this even better. If you travel to the past and change something, you simply fork into a new timeline. No paradox, just a parallel version of reality where you made a different choice. Your original timeline remains untouched, just grumpy that you left. That's comforting in a mind-melting way. But here's the philosophical sucker punch. Even if time travel were possible, you might not be you anymore once you use it. Because your identity is tightly wrapped in memory, causality, experience. If you changed your past, your future self, your mind, your body, your memories might unravel. A different you, shaped by different events, would take your place. Time travel wouldn't just be risky. It would be transformational. And maybe that's the real horror of it. Not paradoxes or timelines collapsing, but the quiet realization that your sense of self is anchored entirely to the flow of unbroken, linear time. Remove that, and what's left? Let's take a step back, or forward or sideways. Think about your own life, the way you return to past moments, not physically, but emotionally. You rewatch old shows. You smell a familiar perfume and get punched in the memory. You reread ancient texts. You listen to music that brings back people who no longer exist in the same way. Isn't that a kind of time travel? Soft, sensory, invisible. You loop through your own timeline constantly, revisiting, reinterpreting, shaping your present with echoes of the past, projecting your present into imagined futures. Time travel already happens, just inside your head. Fringe tidbit: there's a neurological condition called chronesthesia, the brain's ability to mentally project oneself backward and forward in time. It's not memory, it's not imagination, it's the unique human ability to navigate time in the mind. You can run simulations of your future, reconstruct versions of your past. Animals don't appear to do this, not in the same rich, reflective way. You're not just in time, you're mentally across it, constantly. So maybe you don't need a machine, maybe you are one. A fragile, meat-based, surprisingly poetic time machine, blinking its way through memory and fantasy, experience and prediction. Which is kind of magical when you think about it. You are the only known creature in the universe that wonders what would happen if you went back and gave your past self better advice. Even though the laws of physics might let you try. You rewind the tape in your mind, not to a memory, not to a mistake, but to a question. What causes what? It seems obvious, right? A causes B leads to C. Spill your coffee, stain your shirt, have a bad day. Cause and effect, simple. But in the world of time, nothing is ever simple. Because causality, the sturdy, comforting idea that events unfold in a reliable sequence, starts to wobble when you look too closely. In some corners of physics, it even folds in on itself. The timeline loops. The effect becomes the cause. The snake of reality eats its own tail. Welcome to the land of causal weirdness. Population, you, your espresso, and several thousand extremely confused physicists. Let's start with the basics. In classical physics, causality is sacred. One event leads to another. You throw a rock, a window breaks, but in quantum mechanics and general relativity, causality can be negotiable. Remember those closed time-like curves, CTCs, from last time? Those elegant mathematical loops in spacetime that allow an object to arrive at its own past. Yeah, those are a problem. Because once you allow time loops, you allow causality to eat soup with a fork. Let's say you invent a violin. A century later, someone travels back in time with your design. They show it to you, and that's how you learn to make a violin. So where did the design actually come from? That's the bootstrap paradox. Information or objects with no origin just cycling through the timeline endlessly. Created by no one, caused by nothing. Historians still argue whether the earliest formulations of this idea came from science fiction or pure math. Either way, it's unsettling. It implies that some events exist in the universe without a first cause. They're self-originating, spontaneous, paradox-proof but logic-breaking. And it gets weirder. Let's talk about an experiment called the quantum switch. This isn't theoretical. This is real physical lab work involving photons and interferometers. Classic, let's confuse the universe stuff. In the quantum switch, two operations, let's call them A and B, are applied to a particle. In classical reality, either A happens before B or B before A. One has to come first. Right. But in this quantum setup, A and B exist in a superposition of orders. There's no clear before or after. The particle is processed in both sequences simultaneously. The timeline isn't fuzzy, it's undefined. Which suggests that in the quantum realm, causal order might not be fundamental. It might emerge only when we observe or measure a system. Like time, causality could be a property of perspective. And if you're already picturing a world where who caused what is a meaningless question, yes, welcome, you've arrived. Some theoretical physicists are even toying with models of indefinite causal structure, universes where events don't have a strict order, where the sequence of cause and effect isn't fixed but flexible, contextual, dependent on other interactions. You could tell someone, "I tripped because I sneezed," and they could reply, "No, you sneezed because you tripped." And both might be correct. You could be the cause and the effect, just depending on how you observe the system. Take a breath, that one bends the brain. And then there's the retrocausality rabbit hole, the idea that the future might influence the past. Not in a poetic, fate-laced, my destiny shaped my childhood way, but in a real, testable quantum way. Some interpretations of quantum mechanics suggest that measurements in the present could determine the state of a particle in the past, not just reveal what was already there, but actively influence what happened. This has led to all sorts of philosophical head-scratching. Did the outcome already exist and we just revealed it? Or did our choice of how to observe it create the outcome? And if so, when? In one formulation, the transactional interpretation of quantum mechanics, interactions involve waves traveling forward and backward in time. Every quantum event is a handshake across the timeline. Past sends a wave, future sends one back. The transaction completes. No fixed cause, just mutual agreement. It sounds like sci-fi, but it's mathematically clean and extremely annoying to people who like their timelines straight. And yet, we still live our lives as if cause and effect are solid. You don't think, "My future lunch might influence my past breakfast." You think, "I forgot to eat and now I'm cranky." The arrow of cause is so deeply embedded in your language, your thinking, your stories. But physics whispers something more ambiguous. That maybe the universe doesn't mind if you build a violin from nothing. That maybe reality has space for events that are their own reason. That perhaps your choices echo backward, not just forward. Quirky side note: the laws of physics that allow time loops also allow information loops. In theory, you could receive a piece of information from your future self, use it, and then send it back. That's right, you could get tomorrow's lottery numbers from yourself and then ensure you had them all along. And while it sounds ridiculous, in a spacetime with CTCs and exotic matter, it's logically consistent. Horribly inconvenient for free will, but consistent. So why don't we see these paradoxes in real life? Well, probably because we live in a universe that prevents them. Time loops, if they exist, may be limited by physical laws we don't yet fully understand. Or maybe paradoxes aren't forbidden, they're just self-resolving. There's a concept called the Novikov self-consistency principle. It states that if time travel is possible, the events that occur must be consistent with the timeline. You can't go back and change things in a way that creates contradictions. You can interact, but you can't disrupt the loop. You might drop the violin, you might forget a note, but somehow the design still makes it to the past. Like a perfectly tangled knot, unruly but unbreakable. So what does all this mean for you, here and now? It means causality might not be as clean as you want it to be. That your life, the neat sequence of this then that, could be underpinned by a far stranger logic. One where effects ripple backward, where timelines curve into themselves, where your future self may already be leaving breadcrumbs behind you. It also means that your existence might not be a simple path from cause to effect. You might be the middle of a loop. A moment that happens because it already happened. A spark flickering in both directions at once. And in this moment, this shimmering, self-aware stretch of consciousness, you are both the echo and the origin. You blink and the room shifts, not dramatically, not with fanfare, just subtly. The air feels heavier, or lighter. Something in the lighting bends a little. It's not déjà vu exactly, but it rhymes with it. You've been here before, but you haven't, or maybe you have, but not yet. Time suddenly feels like it's folding inward, like you're in the middle of a loop you didn't notice until it bent just the right way. This is where things get personal. Because for all the cosmic machinery we've explored, black holes and block universes, quantum fuzz and causality knots. There's one-time machine you carry with you every single day. Your mind. And sometimes it glitches. You felt it, those eerie moments where reality repeats itself. A sentence spoken that you've definitely heard before. A gesture, a pause, a smell, like a ghost brushing against your timeline and whispering again. Déjà vu, dream loops, time slippage during trauma or ecstasy, the sensation that you've been somewhere before being there. It's all part of the strange, deeply unscientific, but impossible to ignore, friction between your brain and time. Let's start with dreams. You close your eyes, slip beneath consciousness, and enter a world where time isn't linear. It's a storm. You fall asleep at midnight and live a whole day in your dream. Or you blink and a dream collapses just as it begins. Hours vanish. Seconds stretch. You run in place. You return to rooms you've never seen before but know intimately. Time in dreams doesn't behave. And that's not a metaphor. Your internal sense of time really is different while dreaming. The brain's frontal lobes, responsible for logic, sequencing, and time awareness, are partially offline during REM sleep. That's why you don't notice the absurdities. Why you don't question how you got from your childhood home to a pirate ship to your old high school prom. Historians still argue whether ancient cultures saw dreams as glimpses into a nonlinear time, visions of past lives, or future events, or symbolic echoes rippling through some deeper dimension. Modern neuroscience chalks it up to memory sorting, sensory processing, and low-stakes simulation training. And yet, every once in a while, a dream feels like a message. Like it already happened. Or like it's going to. That brings us to precognitive dreams, a deeply fringe topic with just enough tantalizing anecdotal evidence to keep people curious. Countless individuals report dreaming of events before they happen, conversations, encounters, accidents, enough to fill entire Reddit threads and several questionable books. Science doesn't endorse this, mind you. There's no reproducible evidence, but your brain is an excellent pattern detector. Sometimes it predicts correctly, sometimes it wants to. And then there's déjà vu, the king of the mental time loops, that eerie, prickling sensation of reliving the present, of remembering now, not remembering something that happened, remembering the experience of experiencing this moment as it happens. Déjà vu has many proposed causes. One theory suggests it's a glitch in memory processing, that your brain files a new experience into long-term memory a fraction of a second too early, then retrieves it instantly, creating a false sense of familiarity. Another posits cross-communication between brain hemispheres, where one side processes a stimulus slightly before the other, creating a lag that feels like repetition. There are even theories involving micro-seizures in the temporal lobe, or moments of delayed neural feedback, but none of them fully capture the uncanniness of it. Because déjà vu doesn't feel like a mistake. It feels intentional. It's a time wrinkle, a folded moment, a glitch in the matrix if you're feeling theatrical. And it's not alone. There's jamais vu, the reverse. Familiar things suddenly feel unfamiliar. You say a word so many times it becomes nonsense. You look at your own hand and briefly think, whose is that? There's presque vu, the tip of the tongue sensation, the feeling that you're almost recalling something just out of reach, like a memory is trying to travel backward to you but keeps slipping. And there's chronostasis, a fun little perceptual trick where time seems to stop momentarily. You glance at a clock, and the second hand seems frozen for a moment before ticking forward. That's your brain patching over the blur that happens when your eyes jump. These are the mental hiccups that prove your perception of time isn't objective. It's handcrafted, a personal hallucination made to look seamless. But sometimes the curtain slips. People in altered states, due to psychedelics, trauma, intense meditation, or even fever, often report nonlinear time experiences. Time slowing, time looping, time fragmenting into frames. Some even describe feeling outside of time altogether, as if watching their life from above or beside. A study from the 1960s on LSD users found that many experience time dilation, describing minutes as hours or entire lifetimes unfolding in single moments. This wasn't metaphorical, it felt real to them. Quirky fact: one subject claimed to have watched the birth, life, and death of a civilization inside a raindrop, which is either profound or very, very inconvenient. The brain on psychedelics often loses its grip on sequence. Causal order dissolves. Moments collapse into each other. You feel both ancient and newborn, infinite and fleeting. This isn't just drug-induced chaos. Some philosophers and neuroscientists argue that these states reveal the underlying subjectivity of time, that your normal timekeeping is just the brain's default mode, and these experiences pull back the curtain. Of course, not all loops are mystical. Sometimes the mind repeats itself because it needs to. People with PTSD often re-experience moments of trauma, not as memories, but as if they're happening again. The past intrudes into the present. Time fractures. In extreme cases, trauma can distort time so thoroughly that years feel compressed into moments, or moments stretch into years. Survivors often describe events as both too fast and unbearably slow. Time becomes not a line but a spiral, a trap, a wound that keeps echoing. But not all loops are painful. Some are musical. You hear a song from your childhood and time folds in on itself. You're there instantly, not remembering being. A smell, a word, a face. Any of them can twist the arrow of time into a circle and send you spiraling through memory like a comet. You don't control these loops, you live in them. And maybe, just maybe, that's what time really is. Not a straight road, not a ticking metronome, but a tangled net of lived moments, some sticky, some slippery, some looping back in on themselves, not because of physics, but because of meaning. You've traveled through time more than you realize, not in a machine, not through a wormhole, but in your dreams, in your grief, in your joy. You revisit the past every time you remember. You glimpse the future every time you hope. And sometimes, just for a second, you feel the loop close. You sit there blinking, maybe yawning, and for a moment everything feels fast, not in the panicked, deadline-chasing way, just fast in the existential sense, like your life is slipping by in increasingly blurry snapshots. You remember summers that lasted forever, school years that crawled. Now, decades seem to pass in the time it takes to write a single email. So the question is this: why does time feel faster now? Let's start with something uncomfortable. Your perception of time is broken. Not in a malfunctioning way, but in a deeply human way. Your brain wasn't designed to keep track of time accurately. It was designed to interpret it. And that interpretation, it changes. Children experience time differently than adults, not just because they're smaller and smell like glue, but because their brains are new. Everything is novel. Every smell, taste, noise, sensation. It's all unfamiliar and worth remembering. And here's the crucial bit. The more memories your brain encodes, the longer that period feels in hindsight. Your childhood summers weren't longer. They just left deeper footprints. Historians still argue whether this subjective distortion of time perception was widely recognized in ancient texts, though some philosophies, like the Buddhist concept of impermanence, hint at an early awareness of time's slipperiness. In modern neuroscience, the phenomenon is well documented. We tend to judge the length of time based on event density. More events, longer perceived duration. Fewer events, time collapses. It's why a boring meeting feels endless while an exciting vacation feels like a blink and then fades into a blur. This also explains the time compression effect. When you reflect on a routine stretch of your adult life, it often seems like nothing happened. Where did those months go? You ate the same cereal, drove the same road, answered the same emails. Your brain, ever efficient, tosses the whole block into the mental equivalent of a miscellaneous folder. But when something new happens, time expands. The first time you visited a new city, the first time you held your niece, the first time you got lost in a forest or in someone's eyes, your brain carved space for those moments, and space in memory feels like time. Want time to slow down? Do something you've never done before. Take a different route home. Learn a language, sleep in a tent, shave your head. Anything that forces your brain to stop autopiloting and pay attention. Let's pause for a quirky fact. In one study, researchers found that people placed in unfamiliar environments consistently overestimated the passage of time, while people in predictable settings underestimated it. That's right. The more uncertain you are, the longer things feel, which means your brain uses uncertainty as a clock. That also explains why crises, car accidents, earthquakes, breakups feel like they last forever while they're happening. Time doesn't actually slow down. Your brain just goes into high-resolution mode, storing every detail. Later, when you recall it, that moment feels huge. Now let's talk about aging. There's a common theory called proportional time perception. It suggests that as you age, each year becomes a smaller fraction of your life. To a 5-year-old, a year is 20% of their existence. To a 50-year-old, it's just 2%. So time feels faster because it is smaller relative to your total memory bank. It's elegant, a little sad, very persuasive. But not the whole story. Because recent studies suggest it's not just about proportion, it's about attention and routine. Adults tend to stop paying attention to time in the same way children do. We fill our lives with structure, tasks, goals. We schedule our days into neat little boxes and then wonder where the years went. You can almost hear time whispering, "You weren't looking." And then there's culture. Not everyone experiences time the same way. Some cultures are monochronic, linear, punctual, obsessed with schedules. Others are polychronic, flexible, relationship-based, time fluid. In parts of the world, being on time means when the rice is done. In others, it means if you're not 10 minutes early, you're late. Your internal time perception is shaped by how your culture talks about time. In English, we say time is spent, saved, lost, or wasted, as if it were currency. In other languages, time is passing or flowing. In some, there's no strict tense system at all. Fun side note, the Amandawa people of the Amazon reportedly don't have a word for time as an abstract concept. They don't age into numbered years. They move into roles: child, parent, elder. Time to them is social, not numerical. Which makes you wonder, if you stopped counting birthdays, would you feel them as strongly? Now let's talk about your environment. Your room, yes, this one, might be speeding time up. Research shows that time perception can be altered by light, color, ambient noise, and temperature. Red lighting can make time feel faster. Cold environments can make it feel slower. A ticking clock in a quiet room, that'll make minutes stretch like hours. And here's something oddly poetic. People with depression often experience time as slower, while those with anxiety experience it as faster. Because your emotional state doesn't just tint your view of the present, it bends it. You don't feel time, you feel yourself in time. And then there's technology. You scroll endlessly, swipe repeatedly, binge entire seasons in one sitting. But when it's over, your memory has stored very little, just a highlight reel, a few quotes, a couple of memes. The experience was long, but the memory short. This is called temporal saturation. Your brain gets overwhelmed and stops recording everything. It edits, and when you look back, the time seems to have evaporated. We live in a world that encourages that. Short videos, rapid-fire updates, notification loops, and each one chips away at your sense of spaciousness. So what can you do? Slow down, sure, but that's vague. Instead, try novelty. Interrupt the routine. Practice noticing. Spend an hour where you don't do anything except observe. Watch how sunlight moves across your blanket. Trace the outline of your own hand. Listen to a song and do nothing else. It'll feel slow, boring even. But later, when you look back, it'll feel like more happened. Time didn't speed up, you just filled it. And maybe that's the secret. Time feels fast when we rush past it, but it expands beautifully when we step inside. So the next time you say, "Where did the week go?" maybe take a moment to ask instead, "Did I really live it?" You stretch just a little and glance at the clock again. Still there, still ticking, still smug. And yet, if you peeled away all the alarms, schedules, calendars, and time zones, what would be left? The sun rises, the moon wanes, you feel hunger, you feel tired. But would you still say that time exists? Or would it vanish without the language to describe it? It's time, of course, to ask the deeply uncomfortable question. What if time is a human invention? Not in the "we made up seconds" sense, that's obvious, but in the deeper, more reality-shaking sense. The kind of idea that suggests time might not be a property of the universe at all, but a narrative we've created to keep ourselves from unraveling completely. Let's start with a simple observation. Timekeeping is cultural. Different societies have carved, shaped, and bent time into radically different forms. Not just calendars or clocks, but entire relationships to time. How it's measured, how it's felt, how it's honored or ignored. Take the newer people of South Sudan. Their language and daily lives don't revolve around a clock or abstract hours. Instead, their time is event-based. You do things when certain conditions are met, when the cows return, when the sun reaches a certain angle, when the rain falls. Their time is embedded in nature, not numbers. The Amhara of Ethiopia use a clock where the day begins at sunrise. So 7 a.m. Western time, that's hour one of their day. Meet me at 2 means 8 a.m. by Western standards. Confusing. Not if you grew up with it. In fact, their version makes more natural sense, tying time to light, not to a mechanical cycle. Anthropologists studying such cultures note that linear time, the idea of a straight line from past to future, isn't universal. It's a Western invention, or perhaps more accurately, a colonial export. And like most exports, it's been packaged, standardized, and globalized, whether or not it fits the local shape of life. In many indigenous cultures, time is cyclical. Events repeat, not identically but rhythmically. Seasons, ceremonies, migrations. Time isn't a path, it's a pattern. So what happens when we impose our invented version of time, grids and clocks and quarterly goals, onto people who see the world in circles? You get confusion, resistance, resignation. In the 20th century, missionaries and colonial administrators often forced clock time onto indigenous communities. Agricultural calendars were replaced with Western fiscal ones. Ritual time was displaced by work schedules. Elders who once told time by the stars were told they were late for appointments. Historians still argue whether this process was modernization or cultural erasure. Spoiler, it was both. But here's the part no one likes to admit. The modern concept of time, the one you live by, isn't ancient. It's not eternal, it's not natural, it's industrial. The obsession with measuring, saving, and selling time came with factories. In the early 1800s, time became money in a very literal way. If you were working a loom or a steam engine, your labor could be divided into hours, your productivity quantified. Employers installed time clocks. Shifts began. Breaks were timed. You were paid by the hour. Time was no longer yours, it was rented. And just like that, time became a commodity, a resource, something you could waste, lose, invest, or run out of. The metaphor embedded itself so deeply into your thinking that it became invisible. We talk about spending time, Budgeting time, owing time, wasting time. But have you ever stopped to ask, to whom? That's not rhetorical. Because your understanding of time shapes everything. How you work, how you rest, how you relate to other people, and how you age. If time is a line, then every moment you're not moving forward feels like a failure. If time is a race, then you're always behind. If time is a ladder, you're always climbing. But what if time were a field, or a spiral, or a breath? What if instead of marching through time, you dwelled in it? That's what some scholars suggest. That time isn't something outside of you pressing down, demanding movement. It's something you co-create through your memories, your rhythms, your rituals. Fun fringe tidbit. In Japan, there's a concept called ma, the space between moments. Silence in music, pause in conversation, the absence that gives meaning to presence. Ma isn't just emptiness, it's a kind of time-space awareness. It recognizes that what isn't said, what isn't done, still matters. Contrast that with the Western obsession with efficiency. Productivity culture tells you that time not spent actively doing something is time wasted. But is it? Think of all the best moments in your life. The quiet ones, watching the rain, sitting with someone you love, lying on the floor and doing absolutely nothing. You weren't using time, you were inhabiting it. And there's a name for that too, kairos. Remember kairos from section 1, the Greek word for the right time. Sacred time, time that isn't measured in minutes but in meaning. Kairos is the moment of the kiss, the leap, the whisper. It's when time feels full, heavy with presence. It's the opposite of clock time, chronos, and it's been mostly forgotten in the race to optimize every second. But Kairos is still available, always right now. You don't need a calendar to find it. You don't need a productivity app or a planner. You just need to stop counting, to notice the way light pools on the floor, to let your breath take its time, to speak slower, to listen longer. Because time isn't just outside you, it's inside you. In your pulse, in your breath, in the long blink between thoughts. You are not a machine ticking forward. You are a wave, a rhythm, a brief arrangement of stardust learning to mark its moments with meaning. And maybe, just maybe, time is not real in the way you think. But that doesn't make it less important. It makes it yours. You sigh, roll over, and wonder, for the third or maybe 30th time tonight, what is time really? You're not the first. For thousands of years, philosophers have twisted themselves into logical pretzels trying to answer this question. They've written essays, filled libraries, stared at candles melting slowly down to nubs, all while muttering things like, "But what is the now?" And guess what? They still don't agree. Because while physicists measure time and cultures schedule it, philosophers dissect it. And when they do, time falls apart. Let's start for once in the past with Plato. Plato saw time as a moving image of eternity. To him, the universe had a kind of divine rhythm, and time was simply the way we mortals perceive it. Not a thing in itself, but a shadow of some timeless perfection. You could say he thought time was real, but only as a pale echo of something truer. Then came Aristotle, who tried to be a bit more grounded about it. He defined time as the number of motion in respect to before and after, which sounds impressive until you realize it's basically the philosophical version of saying, time is just counting change. Aristotle thought time only existed if there was change, if something moved, transformed, shifted. No change, no time, which, philosophically speaking, is still hotly debated. Historians still argue whether Aristotle truly believed time was an objective measure or simply a mental framework we apply to the world. Then the clock ticks forward a bit, say, 1700 years, and we find ourselves with St. Augustine, the anxious overthinker of early Christianity. He famously wrote, "What is time? If no one asks me, I know. If I want to explain it to someone who asks, I do not know. which is honestly a mood. Augustine saw time as intimately tied to the human soul. The past exists in memory, the future in expectation, and the present. The present is so thin and fleeting, it barely exists at all. It's the knife edge between no longer and not yet. Centuries later, Immanuel Kant shows up and makes everything worse. According to Kant, time doesn't exist out there in the world. It's not a property of objects. It's a condition of consciousness, something your mind uses to organize experience. You don't experience events in time. You experience events as if they were in time. It's a mental lens, like a pair of 3D glasses you can't take off. Time, for Kant, is like the stage on which your brain forces reality to perform. Remove the observer and the stage disappears. Now take a breath, it gets messier. Enter MacTaggart, the 20th century philosopher who argued that time isn't just weird, it's completely fake. In 1908, he published a paper called The Unreality of Time, not a subtle title. He described two ways of viewing time. The A series, time as past, present, and future, flowing, dynamic. The B series, time as earlier than / later than, static, unchanging. MacTaggart argued that the A series was essential to our experience of time, but also logically contradictory, because every event must be past, present, and future, but not all at once, which means the A series can't exist, and without it, he says, time isn't real. Cue generations of philosophers blinking slowly. And yet, the argument still stands in academic circles. If you can't make logical sense of time as it's commonly understood, how can it be real? There are responses, of course. Presentists argue that only the present exists. The past is gone, the future hasn't happened. Others, called eternalists, say all moments exist equally, like pages in a book. Then there are growing block theorists who suggest the past and present are real, but the future doesn't exist yet. It's being added like Lego bricks. No one can agree. Even today, philosophers of time argue over fundamental questions. Is time an entity or a relation between events? Does time flow, or do we just feel it flowing? Is the future open or already fixed? And if we could step outside of time, what would we see? A fringe but fascinating view, process philosophy, championed by Alfred North Whitehead. He suggested that change is more fundamental than being, that the universe isn't made of things but of happenings, and time is not a container but the very fabric of reality's becoming. In that view, time is the pulse of the universe, the throb of experience. The world doesn't exist in time, the world is time. Which honestly pairs quite well with some interpretations of quantum physics, because at the smallest scales, particles aren't really things either. They're events, interactions, blips in probability, tiny happenings. And then there's the phenomenologists, like Husserl and Heidegger, who weren't so much interested in what time is, but how it feels. Husserl explored the experience of time consciousness, not clocks, not measurements, but that internal unfolding, the way the note of a song holds the memory of the previous notes while anticipating the next. Heidegger, meanwhile, argued that being and time are fundamentally intertwined, that humans don't just experience time, we are defined by it. We exist in tension between what we were and what we are becoming. We are, in his words, thrown into time. Time, in that sense, is not a background condition. It's your essence. You are not a thing moving through time. You are a creature made of time. And once you take that seriously, things start to shift. Maybe that's why you feel anxiety, not because the clock is ticking, but because your very being is unfolding unpredictably. Maybe nostalgia isn't just memory, but a kind of temporal homesickness. Maybe presence is sacred not because it's fleeting, but because it's all you ever touch. Time isn't just a problem for physicists to solve. It's a question for every human to live. What does it mean to be mortal in a universe where time might not be real? What does it mean to hope for the future when the future might already be written? What does it mean to be present in a moment that's always slipping away? Maybe it means what it's always meant. You wake, you breathe, you speak, you love, and every heartbeat says, now, now, now. Even as the philosophers argue. You pause for a long moment, not because you're tired, though you probably are, but because something has started to creep into your mind. A thought, soft at first, but now loud enough to interrupt your scrolling. What if it's all happening at once? Not just metaphorically, not just life moves fast or the past is never really gone. No, something deeper, stranger. A cosmic cheat code whispered by theoretical physics, quietly hinting that the flow of time, past to present to future, might be one big misunderstanding. This is the block universe theory. We've mentioned it before, but now we're going in, deep. In a block universe, all moments past, present, future exist, permanently, equally, simultaneously. Picture time not as a river, but as a landscape. Every second of your life is a point in that landscape. That time you rode a bike for the first time, still there. That awkward Zoom meeting where your mic was on the whole time, still there. That moment still to come when you'll say something brave, also there. You're not moving through time. You're sitting still, experiencing one slice of the loaf. In this view, now isn't special. It's just your location in space-time. Just like there's no universal here in space, there's no universal now in time. The moment you're in August 8th at 11:26 p.m. under a slowly whirring ceiling fan is no more real than the moment in 1420 when someone in Paris lit a candle. They're all equally real, equally present to someone. If that makes your brain melt a little good, that's how you know it's working. This idea flows directly from Einstein's relativity. Remember, simultaneity is relative. Two observers in different locations or moving at different speeds can disagree on whether two events happened at the same time, and both be correct. That means there's no universal now, just a series of nows defined by where and how you are. So if time is relative, if its flow depends on your frame of reference, then why assume it flows at all? Maybe it just is. The block universe takes that idea and runs with it. Every moment exists, eternally. Nothing is becoming. Everything already is. The universe isn't changing its being. And you're a thread through that tapestry, not unraveling, just there. Historians still argue whether the block universe is truly compatible with human experience, because it makes your sense of time, a sense of movement, of change, of anticipation, feel fake, like a trick your brain plays on itself to create continuity. But here's the question that echoes through theoretical physics like a bat signal in deep space. If time doesn't pass, then why do you feel like it does? The answer: consciousness. Your awareness, the steady flicker of self moving through thoughts, is what creates the illusion of time flowing. You are like a flashlight sweeping across a painting. You only see one part at a time, but the painting's already there. The future isn't unfolding, you're just discovering it. That, called the moving spotlight theory. You're not walking through time. Your consciousness is shining on one moment at a time, each fully formed, just waiting to be lit up. Think of all of time as a film reel. You're watching it frame by frame, but all the frames already exist. Kind of like when you rewatch a movie you love. You know what happens. The ending's already filmed, but you still experience it as unfolding, moment to moment, because you choose to watch it that way. The universe might be doing the same thing to you. But here's a twist. If the future already exists in the block universe, do you have free will? Or is it all predetermined, scripted, a beautiful illusion of choice within an already complete story? Well, that depends on how you define free. Some say if you can't change the future, then free will is a lie. Others argue you are the cause of those future events. They're determined by you. So your choices are still real, just already part of the tapestry. It's like reading a novel you've already written. You know the ending, but each sentence still came from you. Here's a quirky side detail. Some philosophers embrace a version of this called eternalism. It says time is like space. Just as all locations exist simultaneously, so do all moments. There's no passage of time, just location in time. Which means somewhere, right now, your great-grandparents are meeting for the first time. Somewhere else, your future self is staring into a different night, asking a different question. And somewhere else entirely, your last breath is already exhaled. All real, all present, all unchangeably you. If that makes you sad, consider this. It also means nothing is ever truly lost. The people you've loved, the places you've left, the versions of yourself you thought were gone forever, they still exist, carved into space-time like fossils in stone. And when you miss someone, you're not just remembering. You're touching a real place in the block, a moment that still exists. You're looking across the landscape and whispering, "I see you." Now, of course, the block universe isn't a proven fact. It's a model, a lens, one of many theories trying to make sense of the strange, stretchy, sideways mess that is time. Other theories, like presentism or the growing block, try to keep time flowing to preserve the becoming of things. They argue the future doesn't exist yet, that it's still being made, that the block is under construction. But relativity disagrees, and so do many physicists. So you're left with a possibility that feels spiritual, existential, and vaguely disrespectful to your planner. That everything that has happened and will happen is already happening. All at once. And your life, it's not something being written. It's something being read. You close your eyes and imagine it. What would it feel like to step outside time? Not just to pause it, not just to slow it down, but to truly exit the flow, like pulling yourself from a river and watching it rush by without you. No deadlines, no birthdays, no aging, no seasons, just stillness. People have tried. For as long as we've felt the pressure of the ticking clock, we've fantasized about escaping it. And some, they've gotten close. Let's start with the most obvious timeout specialists, monks. From Tibetan Buddhist caves to Catholic cloisters, from Sufi hermits to Jain ascetics, spiritual seekers across cultures have aimed to step beyond time, or at least beyond its everyday grasp, through silence, through repetition, through isolation, through meditation. They wake not to alarm clocks but to light. They mark their days not with meetings but with rituals, and in the stillness of their lives, something remarkable happens. Time softens. They describe a sense of presence so deep that before and after lose meaning. A state where you aren't watching time, you're simply being, breathing, sitting, watching shadows move across the floor but not measuring them. Historians still argue whether monastic orders developed these practices explicitly to defy time or simply to refine attention. But either way, the result is the same. A life not ruled by the clock, but by rhythm. Not quantity, but quality of presence. Now let's go orbital. You, think astronauts, zipping through space at 17,000 miles per hour, would be obsessed with time. After all, the International Space Station experiences 16 sunrises a day. That's right, day and night cycle every 90 minutes. Time gets chaotic. But what many astronauts report is something different, a kind of temporal detachment. Time stops being about hours. It becomes about windows, when to sleep, when to float to the next task, when to look down at Earth and forget everything else. Some describe a sensation called the overview effect, a shift in consciousness that comes from seeing the planet as a whole. No borders, no countries, no calendar, just a blue sphere suspended in darkness. In that moment, they say, time doesn't feel like a straight line. It feels fragile, invented. Others have tried to escape time by removing all its cues. There was the famous French cave experiment in 1962. Mitchell Siffer, a geologist, descended into a dark cavern for 2 months with no clocks, no sunlight, no external indicators of time. He recorded his sleep, his meals, his thoughts. By the end of it, he had lost track of time entirely. Days became guesswork, weeks compressed. He thought he'd been down there for 25 days. It had been 59. Later experiments in similar settings showed the same results. Without external structure, your internal time perception drifts. Some people's days stretch to 28 hours. Others compress time until they lose entire weeks. The brain, it seems, needs structure to maintain time. Remove the scaffolding, and time becomes a fog. But what about modern, everyday people? People like you, maybe, who just want a break. There's a growing movement of people trying to live outside time, or at least outside the mainstream's version of it. They reject the 9 to 5, the 5-day work week, the productivity grind. They build lives that follow natural light instead of office lighting, circadian rhythms instead of alarms. They call it time freedom. Digital nomads, off-gridders, remote workers designing lives where time bends to them, not the other way around. No morning rush hour, no unpaid overtime, no panic on Sunday nights. Just space. A quirky footnote here. Some extreme minimalists refuse to wear watches or check the time at all. They wake when they wake, eat when hungry, work when inspired. It's chaos, it's liberation, it's probably a little impractical. But it's a rebellion against the tyranny of minutes. And here's the question behind all of this. If you remove all external measures of time, do you still age? Yes, but you might not feel like you do. Studies on people in time-detached environments show reduced stress, lower cortisol, more stable heart rates, the kind of biological calm that feels like youth, like ease. And maybe that's the point. Time still passes, but it doesn't press down as hard. In some traditions, escaping time is the final goal. Buddhism, for example, speaks of nirvana, a state beyond suffering, beyond desire, beyond the cycle of rebirth, beyond samsara, which, not coincidentally, is often described as the endless wheel of time. In Hinduism, the great god Vishnu sleeps between creations. In that sleep, time itself dissolves. No world, no becoming, just being. And in Christian mysticism, eternity isn't just a really long time. It's a state outside of time altogether, a timeless communion. These aren't just metaphors. They're attempts to describe what it might mean to exist without a ticking clock. And even in secular terms, we chase the same sensation. You've felt it. In flow state. That moment when you're writing, painting, playing, building, and suddenly look up to realize hours have passed. You weren't bored. You weren't watching the clock. You were inside the moment. Psychologists call this temporal dissociation. It's one of the most reliable markers of happiness. And yet, we rarely design our lives around it. Instead, we return to schedules, to notifications, to reminders that time is money, even though we invented both. But if monks, astronauts, cave dwellers, and musicians all find ways to step outside time's grip, maybe you can too. Not forever, not dramatically, but just enough. Enough to breathe slower, to notice the wind, to feel a moment stretch until it becomes soft, golden, and unmeasured. Because maybe escaping time doesn't mean abandoning it. Maybe it means reclaiming it. Living not by numbers, but by presence. You lie back now, letting the edges of the day blur. Your limbs are heavier, the light is softer, and there's only one idea left circling the drain of your thoughts, gentle but insistent. What are you really in time? Not a question you answer with facts or equations. This one is more like a whisper from the edge of the infinite. Because after all the clocks, paradoxes, loops, illusions, and cosmic geometry, we arrive at a strangely poetic conclusion. You are not a thing in time. You are a temporary event. And there's something beautiful, terrifying, yes, but beautiful about that. You are not a fixed object being carried along the timeline like cargo on a conveyor belt. You are a pattern, a wave, a brief, blazing configuration of atoms that flares into awareness, dances for a while and dissolves. Think about it, your body is constantly changing. Your cells regenerate, your memories shift, your thoughts flicker. The you from 5 years ago is not the same person lying here tonight, not biologically, not mentally, not even legally probably. And yet there's a sense of continuity, an illusion of self, a story you tell yourself to give shape to the motion. You are a sequence, not a statue. Like a song, like a flame. You are a moment that persists by changing. And that makes you incredibly fragile, but also incredibly real, because everything real is temporary. The stars burn out, the mountains erode, the galaxies collide. Why should you, little carbon-based comet of a person, be any different? Philosophers and scientists alike have wrestled with this. Are you a substance or a process? Are you being or becoming? Process philosophers would say you are pure becoming, a phenomenon that emerges briefly, like a whirlpool in a river. You exist not as a solid thing, but as a pattern of movement, interaction, memory, attention. Pull any one thread out, and the whole tapestry shifts. And when the movement stops, so do you. But that doesn't make you less real. It might make you more. Because if you are a temporary event, then every moment you experience is precious. Not because it lasts, but because it doesn't. Your life is a limited edition, a rare configuration of spacetime that will never occur again in exactly the same way. You are not just in time, you are a unique expression of it. Fringe science alert. There's a theory, entirely speculative, that consciousness is a localized ripple in the quantum field, like a momentary flare that arises and falls away. If that's true, then your mind is quite literally a wave event, not an object. You're not a pebble dropped in the stream. You're the splash. Historians still argue whether ancient philosophies hinted at this long before physics caught up. Many mystical traditions suggest that the self is not a fixed soul, but a flicker of awareness moving through illusion. In Buddhism, the self is anatta, non-self. In Taoism, you are a momentary expression of the Tao. In Stoicism, you are but a breath of the whole. So if you're not fixed, then what is there to hold on to? Maybe nothing. Or maybe that's the wrong question. Maybe the goal isn't to hold on, but to flow with it. To live this brief, luminous event that is you with attention, with compassion, with just enough curiosity to make the days matter. Because here's the strange comfort at the heart of it all. If you're a moment, then you are always becoming, always unfolding, always rearranging yourself. You are not trapped by your past. You are not limited by the shape you took yesterday. You are a little burst of spacetime, constantly writing itself. And when your moment ends, you return to the field, the stars, the carbon cycle, the soft hum of matter doing what it's always done, organizing, glowing, dissolving. Your story becomes part of everything else. And maybe, in some strange sense, it always was. Because remember the block universe. If that model is true, then this moment, this exact version of you lying quietly, listening, wondering, is eternal, etched forever into the structure of reality, not fading, not passing, just there always. You are a coordinate in spacetime, a poem pinned to the page. And while the you of tomorrow may move on, this moment will always exist, as real as any other.